Course.
Hello and welcome. Good afternoon, everyone. My name is Katie Fitzgerald, and I'm the Associate Director of the National Air Filtration Association. Today's webinar is Best Practices for Air Filtration in Data Centers with Tim Mohan. Before I hand it over to our moderator, Ian Wright, I want to remind you that NAFA is your #1 source for education and best practices in air filtration. There is still time to register for our upcoming 44th annual convention. It'll be hosted in the lovely Newport, Rhode Island. If you're a manufacturer, business owner, it's not just technical content, but it's also a great place to discuss the air filtration business. Fantastic networking. So bring your spouse or a companion. We hope to see you there. Also save the dates. The TechSem 2026 is going to be in Louisville, Kentucky. We will open registration December this year. This is more highly technical content. Sales folks, engineers, as well as owners attend. It's very condensed content with lots of research shared. Also free on the NAFA website is our best practice guidelines, a practical way to apply a standard. ASHRAE creates the standards and NAFA helps you apply them. You can brand these guidelines and leave them behind as an educational tool for your customers. NAFA has all of our best practices guidelines on our website. It's the best way to apply the standards on the ground, so to speak. All of our guidelines are available on our website to download for free and also brand with your company logos. And don't forget that NAFA brings a ton of content through various channels with active social media and podcasts. You can consume air filtration content and discussions at your convenience. We don't want to forget to thank our platinum and gold sponsors for NAFA. We couldn't do it without them. They will be in attendance at the annual convention, so stop by and thank them for all of their support. I'll now hand it over to our moderator, Ian Wright. Ian is the Education and Training Vice Chair. Thank you, Ian, for your contributions in moderating our webinar today. Take it away.
Absolutely. This is a fun one. I think when people see, data center, they get excited. So it's my privilege to introduce kind of one of our young trailblazers in the world of HVAC and facility management. We're here today with Tim Mohan, better known as Tim. He's the president of Tri-State Filter and HVAC Supplies, the mastermind behind Omnisphere Consulting. Tim has over 20 years of experience in working with facility managers and engineers looking to supercharge air filtration, energy efficiency, mechanical projects, kind of all the things that most of us go out on a day-to-day really to kind of capitalize on. So Tim doesn't just run the show at Tri-State. He also, like I said, founded and is a principal consultant of Omnisphere, where he works to craft ingenious solutions for facility management, inventory development, procurement, and keep the commercial and industrial clients ahead of the curve. Just wait, there's more. Tim's a thought leader who's also helping shape our future of our industry. He's penned some insightful white papers on cloud-based supply chain management and contributed to the key guidelines on air filtration, which we may be seeing some soon, right, Tim?
Yep.
His work is really just about kind of blending the technology that a lot of us talk about, kind of with the efficiency that we also kind of always really focus on. And then really, what is the future of the facilities that we, as whether you're a distributor, manufacturer, really all parts of kind of the NAFA organization, we want to try to figure out what tomorrow's challenges is. And data centers is one of them. It's obviously been very popular in the news and the development and all that. So let's take a minute to welcome Tim, a new leader, and we'll call you an HVAC hero for today as you're talking about the one thing that a lot of people want to talk about, and that's data centers. So take it away, Mr. Tim.
Thanks, Ian. Thank you very much. And do me a favor, when you get a chance, send me that skit because that was pretty awesome.
Absolutely.
I forgot that you were even talking about me for a second there.
Venmo QR code will be at the bottom.
Thank you. Thanks, team. Thanks, everybody, for joining. Thanks very much for NAFA for setting this up. I mean, Katie and Emily and Terry and Ian and Matt, everybody's been really great in setting all this up. So I appreciate the efforts we all put behind this. And today we're going to be talking about the best practices for air filtration in data centers. A little bit of background on me. I've been working with data centers for about 20 years. and I'm still going to pretty much guarantee you that 90% of you know more than I do. So, reason I'm doing this is because I'm one of the lead authors on the guidelines, which should be sent up to the board within the next few days for approval and then publishing. Um, what we're going to do today is we're going to talk about our purpose, our scope, and how we basically came up with this method for creating the guidelines and what are the resources that we touched on, that we referred to, and some things to look out for. All right. Oh, sorry, wrong way, guys. Um, Three things that we try to accomplish with the guidelines for data centers. First, data centers, they protect critical IT infrastructure. Um, we also want to make sure we're paying attention to the air cleanliness, and we want to maintain a reliable standard for air cleanliness in data centers. And then last but definitely not least, the primary function of data centers is to house that critical equipment. And in doing that, they want to do it in the most energy efficient manner. So we'll talk about how air filtration can help with that a little bit as well. So when we're talking about data centers, we're not just referring to those big buildings that have a lot of servers in them. Yes, those are data centers, but a lot of multi-tenant applications and a lot of administrative buildings also house data centers, smaller data centers, maybe server rooms, but they still try to maintain that same level of accountability as if we were talking about a 100,000 square foot complex. So we have obviously the big industrial data centers, we have server rooms, and more popular these days are cloud facility services. And in case anybody's not familiar, a good example of that would be the Microsoft Azure system, where multiple small businesses are also cloud-based. And instead of housing their own equipment, they're renting co-location space, and they're renting space from larger centers. So we've seen that in DC. I believe in the Midwest, they have a lot of them now. They're popping up all over the place, and their load and their requirements are just as critical as the historic data centers that we've seen. Now that we have established what type of facilities we're talking about, we're going to talk about the different ways that we look to meet the requirements. So we've broken down filtration in our guideline into three very general sections. We have the particulate filtration, which is, dust and skin cells and lint and all those, leaves and pollen. We have molecular filtration, which is more along the lines of gas-based. So we're looking to use carbon to help filter out some corrosive elements. That's a natural byproduct of the electronics in the data centers. And in some very rare occasions, we have some ultra clean rooms in data centers. And we're talking about HEPA filtration and how testing HEPA filtration on site to make sure that it meets the very stringent requirements can be met. After we talked about the type of filters we're using, now we want to talk about how we can maintain and monitor those solutions, right? So HVAC integration, whether it's tying into a building management system, monitoring the system using MagnaHelix gauges, and compliance, how these activities are being recorded for any plethora of reasons. It could be to meet certain standards like LEED and WELLs, or it could be something for insurance. All of those things we'll try to touch on a little bit today, and we go into even more detail in the guideline. All right. One quick thing on data centers, just the background. Very interesting thing I learned a long time ago. If you look at the two pictures that we have here, both of them are data centers. And what I first learned is data centers are not flashy buildings. They don't have a lot of neon lights and big signs. And both of these data centers here, they're individual data centers for some of the largest organizations in the world. But they don't want you to know that. And remember, we're storing critical information technology systems. We're storing critical data. One of these buildings houses bank accounts. And what we've learned is, besides the security and besides the maybe dozen or so people that's running a 200,000 square foot facility, that's all you're getting in there. For 200,000 square feet to only have 10 people in that building, it's not because the people are as critical as it is the equipment is critical. So the best way to put it with data centers is zero downtime. And they look for any opportunity to make sure they can hit that. In addition to zero downtime, they want to run this at the lowest possible energy usage. What we'll talk about later on in this specific webinar is how air filters can help us do that. Primary function, like I said, is to protect the equipment. All right, so some important considerations when we're talking about data centers. Obviously, energy efficiency. We also have regulatory and warranty compliance, which starts to loop in manufacturers. What you'll see throughout this presentation is we're always circling around 2 or 3 different key components for these facilities. Relationship with the manufacturers, understanding what the equipment calls for and what the manufacturer is recommending. Also getting feedback from engineers and architects, and also getting feedback from a quality filter supplier, somebody who understands the industry and understands how to properly size and suggest equipment. Other things that we're going to look at: filter life, maintenance scheduling, making sure you're changing that product for the best possible energy efficiency solution, not necessarily when we're hitting that 1.0 or 1.2 or 1.5 on a Magna helicase. System compatibility refers back to what the equipment is designed to use versus what may or may not be the best option for the facility. And lastly, preserving the equipment lifespan. Needless to say, nobody wants to actually run a system and find out that the product you've been putting in there is causing detrimental damage. Some other things that you can find that data centers are doing: VFDs and ECM motors, a newer style of VFD where the control goes on each individual motor. Those types of devices, when used in conjunction with a filter that'll allow you to run at a lower pressure drop, can seriously reduce the amount of energy efficiency load that you're taking. So that's what we want to see. We want to see a very efficient running, low energy usage from your data center. So that's it for the scope and the background. Now we're going to talk specifically about what NAFA best practice recommendations are. I've broken down this next section into basically 2 different parts. We're going to talk about the construction of the filter, what we look for and what we're hoping to achieve. We're also going to talk about the external factors, things that may cause variances in what data centers use. And then we'll go into different types of OEM recommendations. So first, let's talk about the construction. When we're talking construction, we're talking about the size, we're talking about the fit, and we're talking about pleat orientation, gasketing, and material. So what is the ultimate goal here? The goal here is very little bypass. And what bypass is the air that moves around the filter that is not going through the filter. Another way to look at that, that could be unfiltered air. We want as much air to go through the filter pleats as possible. And there are certain things that can refrain us from doing that. One thing that actually refrains us from doing that could be the high velocity of speed in equipment. And what manufacturers have put together is changing the pleat orientation. So if we're looking at the screen here, we see on the left-hand side, we have a 20 by 25 by 2 filter, and those pleats run vertical. Now the same filter also horizontal. Now the pleats are running horizontal. So knowing when to use a reverse pleated filter versus a standard pleated filter in the different types of equipment can have a great impact on how that filter holds up with higher CFMs. Another thing that's very, very popular and becoming even more popular is putting gaskets on the filters. The filter on the bottom we can see here has a neoprene gasket on it. What that does is it helps seal the air, seal the space, excuse me, around the filter to allow for less bypass. Now, I have yet to see a filter that can give you zero bypass. However, we can get pretty close by putting a good quality gasket. So the pleat orientation, putting gaskets, and in some cases, adding clips onto the filters to help fit them in better, have proven great success in eliminating bypass. From a specification perspective, it gets a little bit more interesting because now we're talking MERV rating. Long story short, years ago, we all know it was MERV 8 filters that were the thing. Went up to MERV 13, now MERV 14, in some cases, MERV 16, 15. It's very difficult to sit in one place and say that there is a standard application for every piece of equipment for every data center. However, if you use the resources that you have available to you, getting information from the right engineers, suppliers, getting feedback from the manufacturers, you'll stand a greater chance in choosing the right product for your application. What I drafted here was a little chart that when I saw it helped me, felt like it would help prove my point. So on the bottom, the y-axis, I think that's the y-axis, shows pressure drop. And the left, the x-axis, shows energy efficiency. Now that energy efficiency actually refers to the full unit energy efficiency versus the specific filter or a specific fan. And what we can see with a MERV 8 having a very low pressure drop stands to reason that you're going to have a more efficient fan. Whereas in some cases, like I said, they're using HEPA for clean room. Well, they naturally have a higher pressure drop. And because of that, your fan will have to work harder. Nobody's saying only use MERV 8s, and nobody's saying never use HEPAs. What we are saying is this is something that you should consider and at least understand how it would fall in range of how you're going to affect your fan efficiency. And for more information on this, we could look at the refer to the NAFA guide. And within the first couple of pages, we talk about energy efficiency and full fan efficiency, which breaks down the actual calculation on how this is derived. Some external factors to discuss, where your data center is located. So environmental risks. Here in New York, where I'm based out of, data centers have to protect themselves from saltwater contamination, right? They're right around the Hudson River, or if you're in Long Island and you have the bay on both sides, that saltwater can cause copper pipe to oxidize in a week. I've seen it with my own two eyes. If you're a data center in New York City, you're going to have a ton of exhaust fumes. Also, if you're located on the side of the highway, and you're going to have a lot of exhaust fumes there. If you're a data center in the desert, you may have to protect against sand elements getting into your getting into your outdoor air units, pollen, etc. So those environmental risks should definitely be accounted for when determining the type of filter that we choose. Gaseous contamination. We referred to the ASHRAE Technical Committee 9.9, which basically just talks about thermal guidelines for different environments. What is the allowable temperature? What is the allowable humidity? All different types of energy efficient practices. And what we find is oftentimes one byproduct is copper and silver iodide. And while the actual amount that is allowed is very, very low. I think it's 10 to the negative, no, I think it's 30 to the negative 10 arms. I think they call them angstroms. It's a very small amount, but it does happen in data centers. And we often will see organizations using carbon filters or different types of carbon impregnated products to help mitigate that. And another thing to consider is free cooling. In other words, air side economization. And that's just allowing fresh air into the facility. That's a good thing. We'll talk about the WELL's building standard in a few minutes, and we'll talk about why getting fresh air into the space is good, but it must be conditioned. Otherwise, you're going to be allowing a lot of particulates in here, pollen, leaves, bird feathers. So we'll talk about filtration strategies for that. OEM factors. So I'm a big believer in always involving the OEM, the actually equipment manufacturer, in the decision when we're talking about what type of filters. Oftentimes, they will make recommendations on the types of filters, and more often than not, the facility managers will start with those recommendations for the first change, two changes or so. After a while, we look to improve on them, but not forgetting about what the original recommendation was, because that takes into account flow rates, CFM, sizing, and all different number of things. So we're going to go through a few examples of some popular types of equipment. The actual manufacturer really isn't as important as the type of equipment is, so we'll go through that. First one, the good old CRA unit, computer room air handler, or sometimes we see them as CRAC units, the computer room air conditioner. If it's an air handler, what you're going to see is a coil, a motor, a blower. It gets a little bit more involved with that, but that's essentially what it is. And it's typically taking chilled water from a separate chiller and using that for heat exchange. NAFA's recommendation here is for a MERV 8 pre-filter and a MERV 13 final filter. Now that's saying that it's a two-stage system. If it's a single-stage system, which means it's only using one filter and not one behind the other, NAFA is recommending a MERV 13 filter. For smaller IT rooms and smaller cabinet spaces, you'll find this in maybe smaller business that have a tech closet or something like that. They will come with a OEM washable filter. Typically, it should be replaced every 5 years. However, it should be checked every 3 months and washed every 3 to 6 months, depending on usage. We do not suggest replacing that filter with something else. Sometimes you'll find a manager will come and say, I don't want to use the washable filter. I want to maybe put a pleated filter. The orientation of the filter in that space, and because that unit is so compacted, we find that it's just best to stick with that OEM filter. And the dedicated outdoor air system. This is typically a rooftop unit that brings fresh air into the system, into the facility. NAFA is recommending a MERV 13 high capacity filter. The primary function of this unit, this type of filter, is to filter out large and small particles. So you're not only just getting the bird feathers and the pollen and the sand and all that stuff in the air, but also the smaller particles that you can avoid as well, and keeping that coil as clean as possible. Filtration requirements. So as I said, pre-filters, MERV 8 pleated filters, final filters, MERV 13 rigid. Molecular carbon filtration, we're looking for activated carbon here. And for HEPA, in those very rare cases, 99.97% efficiency with being tested on site. These types of equipment will come in all different ways, shapes, and forms. So you may have an air handler, and the manufacturer only suggested putting a single MERV 13 pleated filter. Okay, so be it. Changing that to a MERV 8, you should consider the high flow rate that equipment is carrying. Some of these equipments can be 20, 30, 40 tons and pushing 50,000 CFM. Putting the incorrect type of filter in this application could very well cause that filter to buckle. So you want to make sure the type of product you're putting in there can withstand whatever the CFM requirements are. Operation and maintenance. So for more information on this, I would strongly suggest we refer to the technical guideline, where we discuss PPE and standard operating procedures and all different types of hardware and materials. It's very well written. We actually referred to the technical guideline when putting together the operation and maintenance section of the data centers guideline. First, for installation, install per NAFA and OEM guidelines. For monitoring, using a functioning magnet helic gauge, I think we've all been to a site and we ask, how are you figuring out where you're going to change your filters? And they say, well, the magnet helic doesn't work. Well, it kind of makes it hard to figure out when you're supposed to change your filters, because all you're doing now is opening the door and seeing if they're dirty or not. Magnet helix play a very critical role in knowing the pressure drop and knowing when to actually change the filter. Also, the newer magnet helic gauges are great because they connect straight to the BMS, so we can actually look at it from the control board and see from the engineer station how much pressure we're pulling on different types of air handlers. We can replace the filters based on usage and performance. I've seen some sites where they like to replace them when it hits 1.5 on the magnet helic. We'll talk about the TCOH report, total cost of handling, in a few moments, and we'll talk about the various differences that you can get if you decide to change based off of a predetermined preventative maintenance cycle versus waiting for the filter to actually fill up. And gaskets and sealing. So I find a lot of groups don't really pay attention to this. When those gaskets start to wear away, they allow for bypass and leakage. So making sure you have a nice form-fitting gasket with a proper seal is absolutely critical. And I strongly suggest that engineers and facility coordinators make that part of the preventative maintenance cycle, looking at things like that. Replacement schedules. Pre-filters should be changed every 3 months. Final filters should be changed every 6 months. And molecular filters should be changed annually based on the condition of the carbon, if it's spent. And HEPA also should be changed every 12 months and tested at the same time. So what we're really saying here is you should do 2 full changes a year, but change your pre-filters every 4 times a year. Total cost of ownership. I think is very important when we're talking about a facility that spends a lot of resources on energy conservation to always have an idea of the total cost of ownership. And what is total cost of ownership? It just takes into account the full cost of owning the filter. This takes into account the actual cost of the product, takes into account the disposal, how much time it takes to change the product, what is the energy cost associated with running that product to the full extent, which could be 1.5 on the magnet helic, or in some cases 1.0 on the magnet helic, versus changing it maybe when it's at a 0.8 or a 0.9. It also takes into account delivery costs on, and I think I said disposal, but it does take into account disposal as well. So in this graph here, we can see, and I think if you take your CAFS exam, the first thing you learn is the total cost of ownership. The actual cost of the filter really only accounts between 15 and 18% of the total cost of ownership. Other costs, like I said, is energy, freight, disposal, changing. What I like to do with all of my clients is at least have them have a report on their desk at least once to let them know this is what it really costs to use this type of filter, versus if you're changing to another type of filter, this is what you're looking at from a total cost perspective. Now we're going to talk about the different types of standards and the compliances that we referred to when we were building this guideline. So the 4 big ones that we use was we use the ISO 14644 for clean room standards. or we referred to the USGBC lead building design and construction practices. We also looked at ASHRAE 62.1 and 52.2. And lastly, the WELL standard for occupant wellness. And we didn't really take too much time and delve too much into the WELL building practices because unlike other Class A spaces, data centers don't have a lot of people in them. They have a lot of equipment, and equipment complains less than people, which is good. But equipment is more demanding than people because if you vary from a standard operation and the equipment starts to fail, you can't say I'm sorry. So for the ASHRAE and the ISO standards, it was paying attention to the filtration levels. Um, like uh, like Katie said earlier, ASHRAE sets the standards, and NAFA will help exercise those standards in practice. ASHRAE recommends a MERV 13. What NAFA is saying is if it's a single stage, we're using MERV 13. However, if it's double stage, you could use a MERV 8 pre-filter with a MERV 13 final filter. Contaminant mitigation using activated carbon. Temperature and humidity management has to be between 40 and 60%. And that's in regards to the technical committee 9.9. IAQ monitoring. Most data centers that I know have monthly IAQ monitoring going on. A third party coming in, they're doing the tests and it's not being handled by the data center employees. Maintenance. Most data centers I know actually do monthly maintenance, but by the time they circle around to each piece of each equipment is getting monitored and maintained on 4 times a year, quarterly. From a lead perspective, lead has minimum indoor and outdoor air, indoor air quality and how to filter outdoor air. Developing strategies and specific guidances for how construction is getting done, what type of maintenance is handled, different types of air quality assessments. And the well building approach, like I said, it's really focused on the occupants of the building. We're not saying data centers have no occupants, but what we are saying is because the primary function of data centers is to take care of equipment, the occupancy is significantly smaller than you would find in an administrative Class A space. And just to wrap up, what we try to accomplish here is put together a NAFA guideline and recommendation for air filtration in data centers. What we've done is we've gone to the USGBC and we've gone to WELL's and ASHRAE and the ISO standards, referred to what they've done, and we've tried to accomplish all of that by putting together guidelines that data centers can use and be functional with. Thank you guys very much for this. I hope I didn't speed through it, and I hope it wasn't too boring. But does anybody have any questions?
Tim, first of all, thank you very much. If you do have any questions, throw them into the chat at the bottom. There's a Q&A button. I do see we have a couple in there. We'll go through. There are a couple that were pre-submitted, so we're going to run through a couple of those, and then I will do my best to kind of manage between the ones we have and then also the ones that have been submitted. You touched on this a little bit, but one of the pre-submitted questions was, is there a typical change out schedule? I know we had the guidelines recommendation of the 3 months on the pre's and then subsequent for obviously as the efficiency goes up. But do we find that data centers are standardizing around a change out, or do you think a lot of them are going off of, Magna Helix and other different types of prompts for change out?
So I see that data centers are locking more into a preventive maintenance cycle and not allowing that Magna Helix to reach. As a matter of fact, let me see if I could do this here. I'm going to try to annotate a chart. Let me see if it works. Please work. All right. So we're going to pretend. Does everybody see this?
Yep, we can see it.
Okay, good. So this is a chart, right? And over here, we're going to call this pressure drop. And over here, we're going to say energy. Wait, that was supposed to be an E. Energy efficiency, right? EE. So as time goes on, that is the curve for pressure drop. So as time goes, the pressure drop will almost exponentially shoot up. And as it shoots up, the cost of using that filter skyrockets. We don't want to change the filter here. We want to change the filter somewhere around here. Before we reach that point, that costs exponentially rise. Now, the finally resistance, let's say it's 1.0 inches of water gauge. Hold on, can I move this out of the way? Yes, I can. This is 1.0 inches of water gauge. And God, please, guys, I'm sorry about my handwriting. The final resistance may be here. But what we're finding is that this may be the 3-month mark or the 4-month mark in some applications. That's where you want to change these filters. You want to change the filter before it reaches that exponential uh, increase in energy usage, but before it reaches that 1.0 gauge. The way we accomplish that, just so we know, is going through a preventative maintenance cycle. Whether or not that filter is hitting 1.0, change it every 3 months or every 4 months, depending on usage.
Perfect. Good answer, Tim. Another question live from the chat. This is one that is there's a little bit of subjectivity in this, but I will absolutely open it up to you in the forum. Is Jeanette Valenti is asking, how will ASHRAE 241 affect recommendations? And I think the broader question there is obviously 241 is a recommendation by ASHRAE. Do you see a lot of the data centers in your consulting work or on the filter side starting to implement some of the recommendations from 241?
I'll be 100% honest with you. I don't know what 241 is referring to, so I can't answer that. I do know that a number of data centers are taking into account ISO, ASHRAE, and LEED standards. Not so much well, like I said.
241 it's like a complementary recommendation from ASHRAE that combines your pre-filter with like other complementary technologies. Sometimes you'll hear about ionization, UV. It's building off of a system of almost like points where you get certain credits for doing different steps along the way.
Oh, okay. I do. Okay. For some reason, I didn't know that was called 241. I just pulled it up and I am feeling, and it's some it has to do with a lot of indoor contamination and aerosols as well. Um, yeah. Short answer is yes. Now, I deal with a lot of building engineers and I deal with a lot of facility engineers and facility coordinators. The third-party testing companies, and there's a few of them nationwide that'll do it. Third-party testing companies will, when they're coming and doing their separate IQ tests on their monthly swabs, they're putting together comprehensive reports. And what I'm finding is, especially with a lot of people I deal with, they'll call me and say, I have a problem. I need to change something on the filtration side because my IAQ company said I'm not meeting a specific standard. How can you help? And then we take a look at what the reports are. It could be for 241, or it could be a swab came back and they had high levels of copper and they needed to mitigate that. And that's what I typically see happening. Third-party companies and third-party IAQ consultants will refer to the ASHRAE guidelines and the ASHRAE guidelines, or if it's the ISO guidelines.
Do you see a lot of them? And this is kind of a follow-up to that, because one of the main premises of 241 is kind of the exchange rates for the air. And
Yeah.
obviously with data centers, a lot of them are closed off buildings that we see.
Yeah.
Specifically from my vector and what I do personally, we get a lot of requests for people that are trying to filter the intake air coming into a data center. But in terms of intake, do a lot of these buildings and stuff calculate air exchanges per hour? Is
Oh,
that a part of the calculus?
absolutely. 100%. Especially because a lot of the air inside data centers is primarily recycled air, right? A lot of these systems are all closed loop. They're only bringing in fresh air to keep levels of carbon dioxide down. I mean, technically that's a little bit of overreach, but Most of the air in data centers is recycled air. The sweet number has always been 8 for some reason. I believe it was 8 or 10. And that's kind of how the systems are sized to get between 8 and 10 cycles.
Perfect. All right. Another question we had here. This kind of touches a little bit, so I don't know if you want to elaborate. You've mentioned it before, the LEED and the WELL.
Yep.
As data centers increasingly aim for sustainability certifications, mentioning LEED and WELL specifically,
Yep.
do you think they will adopt more advanced filter media standards?
I always tell this to every single person who I'm introducing to air filters. So the short answer is absolutely yes, I do think they'll do that, right? Let's just get that covered. It's a corny little thing that I tell people. The perfect filter is a filter that has 100% efficiency with zero pressure drop. And until that filter is designed, I can pretty much guarantee you scientists and manufacturers will keep striving for a filter that will allow for higher efficiency with lower pressure drop. What I'm actually seeing now too is we also want filters that have a positive impact on the, well, I shouldn't say positive, a less negative impact on the environment. Maybe filters that can decompose quicker or are lighter or thinner, because that's the new thing now. Everybody wants a thin filter. It's significantly easier and cheaper to replace. But yes, I do believe wholeheartedly that they're going to be, I wouldn't even be surprised if it's sooner than later, but there are going to be great advancements in the filtration industry. Not from me, because I can't make a filter if my life depended on it, but
Yeah, I think some of us stay on certain sides of the
yeah,
manufacturing side
absolutely.
versus the other side. Let's pull through here. A couple comments in the field. I'm doing my best to kind of bounce back and forth on the let's see. In terms of a lot of the equipment, you mentioned this a little bit when you were going through the different types of units, and that the fact that there's using a lot of water cooling.
Mm,
The question is air filtration not as critical with new data centers because the units are now being water cooled?
no. So the method of heat exchange is mutually exclusive to the filtration of the space, yeah, of the air in the space. You can have a DX unit. So DX basically means you're using refrigerant. You can have a refrigerant cooled system that uses condenser water. How you cool the space has, I shouldn't say no effect, but yeah, the best way to use it is mutually exclusive. You're still going to have to filter the air in that space, whether it's a water-cooled system, whether it's air-cooled. What does take effect is whether or not the air you're using is outdoor air that's been filtered coming in, or if it's recycled air. If it's recycled air, it would require less filtration because that air is just in that space. If it's outdoor air coming in, well, we already know that those rooftop units, or hell, they could be on the side, they're getting, that air is being conditioned coming in. But it does not matter if it's water cooled, if it is DX cooled. I mean, it still has to be filtered, the air, that is.
So do you think that there'll be a competitive advantage for some people that offer both air and liquid? Is that something you see being housed together, or is that something where maybe
Oh,
they
okay.
contract?
Hold on.
No, this is a follow-up question. So
Oh,
this
that's a
is,
follow-up question.
yeah, it's follow.
Okay.
In terms of people that sub out the air versus the water, or do you think that there'll be a mix or cohesion between the two?
So, okay. I'm going to rephrase the question back to you. Can you tell me if I'm asking the right question?
I will do my best. I am not the submitter of the question, but I will do my best.
Okay. So when we're talking about water-cooled systems, we're referring to water basically being the refrigerant, right? And if we're referring to filtering the water, absolutely we should filter the water, but we're filtering it more for scale and sediment. And even that is a closed loop system, which means you're not typically going to add water. So do I think there's a competitive advantage to companies who can offer both air and water filtration systems. Well, Tri-State Filter actually started off as solely an air filter company. We did that for 3 years before I realized these guys are only calling me 4 times a year. There's really, after you sell them filters, there's nothing else to do. We branched off into HVAC supplies, plumbing, facility. One of the best, I guess, best industries we got into was water filtration. So yes, I think there's a competitive advantage to offering both water and air filtration, uh, I guess, products and supplies. But just making sure we're not talking about the same thing. Just because a unit is air cooled versus being DX cooled, they both need to be you need air filters for both of them. And I hope I'm getting the question right.
Yeah, I think one of the things I would maybe take from that is being a little bit familiar with the closed loop systems is, and I think maybe there will be a segue is there anything in that system that could introduce a byproduct that molecular filtration? A lot of times with closed loop systems, sometimes you use chemicals to treat the water and stuff. So I'm going to build off that a little bit and say, are there any molecular contaminants that a system like that would create that you'd need to take into account when designing or selecting filters for different data center applications?
I don't want to say no, but what I feel more comfortable saying is it hasn't come across my list of problems in the past 20 years. One of the biggest byproducts of using water is scale, obviously. If you don't have a proper descaling system or you don't have a catalyst for descaling, and there is a leak, you can come into problems with scale. Technically speaking, too, if there's a bad leak, that can lead to mold. In which case, we're not talking about MERV 8 and MERV 13 anymore. Now we're talking about getting disaster recovery in there, and we're bringing in special scrubbers, air scrubbers with carbon and HEPA filters. But what has happened in the case of bad leaks, where it turns into basically a flood, we have pulled out all of the filters that we typically sell and only sold carbon for a period of time just to help with odors and capturing mold. Although
Okay.
carbon doesn't really do a great job in capturing mold as much as odors, but we did put together special packages of filters for mold contamination in that case because there's water and it could be a flood.
Yeah, and continuing off of that, well, we got a good question from James Fast, and it kind of is on the heels of you have these potential solutions or potential issues that could happen. And one of the things to prevent that is monitoring. And
Hmm.
he asks, are you seeing a shift towards continuous IAQ monitoring versus a spot swab test?
100% shift towards continuous IQ monitoring. 100%. It's to the point that I'm actually on the market right now to find a supplier for a good quality wall-mounted IAQ monitor. Most of the major Fortune 500 companies, I kind of look at them as the red shift, blue shift. They're typically ahead of the curve. Continuous 24/7 IAQ monitoring is now. It's not a thing of the future. What we do have, and what I've seen, and I made mention to it, is a third party organization will come in monthly and swab different sections. And what we hope to see when we look at the reports is consistency. If we don't see consistency, we look at that deviation and we delve further into why is there a deviation? Well, why is the BMS reporting 32 parts per million, but my swab came in at 1100 parts per million? So we look at things like that.
Um, I will add a question here. In terms of data centers, what do you think the biggest challenges are right now for data centers and optimizing the air quality, right? So obviously everybody on this call is going to be kind of more of a little bit of a subject matter expert on the air filters and air quality, but
Mm,
sometimes that information doesn't always translate to the data center manufacturers or the builders. So what are the
sure.
biggest challenges right now as we kind of hit this data center boom with integrating with the best practices, so to say, of the air filtration industry?
Uh, well, I'm going to assume that everybody on this call is either a manufacturer, supplier, or a user in data centers. So I'm going to answer this first from a supplier perspective. I think the biggest challenge is I think the biggest challenge is finding the product that will give you the best quote unquote bang for your buck in terms of energy efficiency. That equipment, when a big data center is getting built, it will ship with filters. Those filters will work. That's what the manufacturer suggested. However, in an effort to cut down on energy costs and try to keep those costs as low as possible, myself as a filtration salesperson will present a client with total cost of handling comparing two different products. Mr. and Mrs. Client, this is what you're using. Here are three options for different types of products that you can use. You let me know what you want to do. No pressure either way. Sometimes they change, sometimes they don't change. The other issue that I see happening actually stems from the supply chain, not necessarily from the data centers problem. I tell my clients all the time, it's my job to have your product when you need it. However, the supply chain and experiencing varying lead times in product, especially for applications where every single month you have to send something, every 3 months you have to send something else, making sure you have that product readily available, specifically for data centers, because it's not like they can say, oh, I missed my change this month, I'll just get it next month. That's not an option for them. So planning, coordinating, and making sure you can keep that energy cost as low as possible, I would say, is going to be the biggest challenge.
Perfect. Well, if anyone else has any other questions that they want to put into the chat, like I said, we did our best to kind of go through and ask and answer the ones we can. There was some questions about MERV 8 and MERV 10, and I always refer people to the ASHRAE charts.
The
Take a
MERV
look
8
at them.
versus MERV 10.
It gets a little bit, down the road of how important are those E2 particles really. So I always encourage people to kind of take a look at that stuff. There was some questions about carbon that were really good in terms of longevity. Hopefully we got some of those answered, but data centers, it's a growing market for our industry, and it's so great to see a lot of the people out here, and great to have you, Tim, out here kind of just sharing years and years of expertise. We all kind of know what you
Like
see
I
in the
said,
field is never what you can learn in a book. So
no, I tell you, I feel like I said, I don't know who's on the call. I feel like I could be one of the least qualified people to come up here and present. But thank you very much.
yes.
It was actually a joy. I enjoyed doing the research, and I actually enjoyed putting together my presentation. So I hope it was okay for everybody. I hope I didn't bore everybody. And I hope everybody walked away with at least something new.
We appreciate your modesty, but always remember, as you said, when picking out the products, that's why the CAFS is so important. That's why the
100%.
NCT is so important. A lot of installation questions, a lot of product selection questions. And as we continue to build out, the resources that NAFA has and starting to increase the credibility and starting to put out certifications of the people out there, that only is going to help facility managers, not only in data centers, but hospitals and other, vectors as well. Always pick the right equipment. We're never gonna wear a team jersey. There's so many great companies out there with so many great products. It really comes down to your application and what's best for that. So, Katie, if you want to jump back on, I don't know if there's anything you have left to plug. We'll hopefully see everybody in Newport. I know I will be there. Katie, you are forced to be there because you have to fill, Tony's shoes. So, anything
Well,
else to wrap us up, or are we going to get on about our Thursdays?
I say we get on with our rest of our day, and we look forward to seeing everybody next month in Newport.
Awesome. Free beers on Tim and Newport.
Love it. Sign me up.
All right, everyone. Thanks so much, and enjoy the recording if it comes out if you have any other questions.
Thank you, everybody. Have a great afternoon.